Welcome to the Explainer. I am your host, but for today's session, you can actually just think of me as your guild master. Because today, we are unfolding a legendary world map. We are diving deep into the Cambridge Mathematics 9709 syllabus, and we're decoding exactly what the examiners are looking for in the conservation of mechanical energy topic. Treat this explainer as your ultimate exam quest. So equip your best gear, focus your mind, and let's start the raid. Okay, let's talk about this number right out of the gate. 15%. That is the massive chunk of total marks this specific topic, energy, work, and power, accounts for in paper 2. And gaming terms, guys, this isn't just some optional side quest you can ignore. This is a mandatory dungeon boss. If you want to clear this level and secure a top-tier grade, you literally cannot bypass this sector. But here's the secret, and it's something I see all the time. Most students approach this boss fight completely unarmed. They just swing wildly with random formulas hoping something hits. Well, Cambridge examiners don't reward random swings. They want to see your mechanics working in absolutely perfect harmony. To secure those marks efficiently, we're going to navigate a 4-part strategy today. First, the 15% stake. Second, core theoretical principles. Third, our standardized processing sequence. And finally, the top 3 examiner warnings.
Let's jump straight into Section 1, the 15% stake, and how we unlock the method mark strategy.
To really understand why this topic demands such structured reasoning, I want you to picture a high-tariff, multi-part Cambridge past paper question. We'll call it the dungeon boss prompt. When you're facing a tricky 6-mark question on a rough inclined plane, that final answer is only worth 1 single point. The entire rest of your score comes from method marks. Think of those as your combo multipliers. The assessment objectives here strictly target 3 distinct cognitive domains, which are basically your skill trees. Level 1 is knowledge and understanding. That's just recalling your formula for kinetic energy. Level 2 is application, right? Substituting the correct mass and velocity into that formula. But level 3, analysis, that is where the elite players live. This is where you encounter what I call the command word runes. If an exam rune clearly says analyze, and you merely state, you've just activated an immediate trap. A student might do absolutely perfect arithmetic, but because they didn't conceptually analyze the friction acting against the system, their entire quest fails and their stamina bar drops to 0. You have to read the runes carefully.
Moving right along to Section 2, core theoretical principles, and going way beyond just rote memorization.
To truly grasp what examiners mean when they talk about connected conceptual understanding, let's picture 2 players sitting at our tactical table. First, we have Alex. Now, Alex is an over-encumbered warrior. He's carrying way too much inventory weight in the form of raw facts and textbook definitions, but he lacks agility. Then we have Sam. Sam is a high-speed rogue who dashes through areas way too quickly and skips mandatory puzzle requirements. So if a block slides down a rough incline, Alex writes out the exact definition of work and the definition of energy completely separately, but he never actually connects them. Sam, on the other hand, is rushing to beat the exam timer, so Sam just sets initial potential energy equal to final kinetic energy and completely ignores the friction trap. Both of them fail the raid. The absolute top-tier strategy here is connected understanding. It's recognizing the causal relationship that initial potential energy equals final kinetic energy plus the work done against friction. That specific connection is the key that unlocks the vault. This exact dynamic brilliantly illustrates the difference between a mid-tier response and true top-scoring analytical depth. Listen to how Alex and Sam debate this. Alex says, well, I should just state the mass and distance in a bulleted list so the examiner knows I read the question. That is superficial analysis. He is just stating facts independently and describing basic data. Then Sam says, dude, the timer's running low. Let's just crunch the numbers, accept the given values, and write the final speed. That is also deeply flawed because Sam is accepting values without any structural precision or evaluating the limitations. As your guildmaster, I am guiding them and you to deep critical analysis. You must set up a framework. You need to use comparative connectives. You should be stating things like, because the surface is rough, mechanical energy is not conserved, therefore we must account for work done against resistance. That one single sentence, that's a critical strike.
You see, you cannot simply extract data from texts and tables and expect top marks. You have to actively interpret the relationships between that data to draw really solid conclusions. If a question gives you a driving force, a resistance, and a change in elevation, well, extracting data just means listing those 3 numbers out. Interpreting relationships means building the master equation. Work done by driving force equals change in kinetic energy plus change in potential energy plus work done against resistance. Cambridge examiners explicitly note in their reports that candidates who build this structural causal relationship immediately jump into the top mark bands. And the best part? They jump into those top bands even if they drop a tiny arithmetic error later on. The architecture of your answer is what truly matters.
Let's shift to Section 3, Standardized Processing Sequence. This is your method mark guarantee. When the exam timer is blinking red and panic starts setting in, you need a muscle memory combo sequence that you can execute flawlessly under high pressure. So use this memory hack. I always execute very perfectly. That stands for identify, apply, execute, verify, and present. Imagine Alex and Sam hit a totally unexpected roadblock right in the middle of a complex connected particles problem. If they try to skip from step 2, apply, straight to step 5, present, it is a total quest failure. You must execute the analysis step by step. You have to let the examiner clearly follow your blade path. Write down every single intermediate calculation. Because remember what we said. Even if you drop a negative sign by accident, the examiner can still award you 90% of the loot for a flawless method. But they can only give you those marks if they can actually see your execute phase mapped out on the page. Quest pause. Real quick, before we unlock the final text block layout to help you conquer your next exam, we need to make sure your guild feed is perfectly optimized. Take a second right now to subscribe to Ace the Exams at handle Ace the Exams and enable all notifications so you never miss our weekly strategic map drops, whether you are traversing IGCSE, O-levels, AS, or A-level territory. Okay, back to the raid. When you reach that final present step, you must strictly follow these conventions. Messy working will completely obscure a perfectly good analysis. Think of this as your final item crafting. If you forge a legendary high-stat sword but you hand it to the merchant covered in mud, they aren't going to buy it. In mechanics, proper presentation means using proper headings. Literally write resolving forces parallel to the plane right above your equation. Use correct terminology. Don't call it movement energy, call it kinetic energy. And use clear annotation, which means drawing a large, well-labeled force diagram. A force diagram is essentially your HUD minimap. If you don't draw the minimap, you and the examiner are going to get completely lost in your own equations. Finally, we've reached Section 4, the top 3 examiner warnings. This is all about protecting your score. This stark examiner alert is a massive red flag on our map. It reminds us that the entire theoretical architecture of this topic rests on precise definitions. Look closely at this quote straight from the Principal Examiner report. The ultimate trap candidates fall into is confusing power, work, and force. Listen to me. They are not interchangeable. Force is an instantaneous pull or push. Work is force multiplied by the distance moved along the line of action. And power is work divided by time or force multiplied by velocity. If you substitute a raw force value into a power equation, your spell fizzles out and backfires on you instantly. The single highest yielding core trend you can take away from this is absolute precision. You must lock in your terminology before you initiate your calculations. So you have to completely avoid these top 3 mistakes. Let's play a quick interactive round of Spot the Defective Item. I want you to imagine a student writes this medium-tier response on their paper. The energy changes because of friction, so the speed is 5 meters per second. Okay, where is the defective item in that logic? I'm pointing my digital laser right at bullet point number 3. It completely lacks specific context. The student didn't quantify the actual work done against friction, and they didn't state the initial energy state. They were far, far too vague. To fix this defective item, the text needs to read more like, since the crate travels 10 meters against a constant frictional force of 15 newtons, the work done against friction is 150 joules, which must be subtracted from the initial mechanical energy. Do you see the difference? That is exactly how you craft a flawless, high-scoring block of text. And just like that, we have reached the victory screen. Alex and Sam have successfully compiled a full mark quest, and your loot drops are looking incredible. As your guildmaster, let me distill this entire simulation into 3 universal rules for you. First, the pre-quest scan. Always, always decode your command words. Second, the pacing matrix. Don't rush like Sam, but don't over-encumber yourself with raw facts like Alex. Use your structured processing sequence. And third, the post-quest checklist. Verify your presentation and your mini-maps. Before you go tackle your next practice paper, hit that subscribe button for Ace the Exams, click the notification bell for our weekly Level Up Masterclasses, and drop a comment below telling me exactly which Cambridge subject and level you are preparing to conquer next. As you close this map today, I want you to ask yourself this one crucial question. When mechanical energy isn't conserved in your next calculation, are you just repeating the data back to the examiner, or are you critically evaluating the specific forces that stole that energy? Good luck on your quest, and I will see you in the next explainer.